Thank you very much. We've heard a lot over the last day and a half about the problems of climate change that are facing us. And we've heard a little bit about some of the global solutions, such as reducing greenhouse gas emissions. But there hasn't been that much yet about connecting the problems, the big global problems that are facing us, with some of the more regional conservation solutions that we might need to adapt and implement. So the focus of my talk today is conservation planning in a changing world, as the title says, focusing on what we can actually do about some of the climate change issues that are facing us. To figure out where I need to point it. There we go. Conservation planning, very briefly, is about aiming to identify the high priority areas for conservation. And Lawrence has talked about this quite a bit, but really what's important here is that globally we still have less than 1% of the oceans protected, and therefore there's still a lot of emphasis that's needed on identifying further areas that need to be protected. Conservation areas in this context could be no-take zones, but they could also be areas that are high priority for other types of conservation actions. What's also significant about systematic conservation planning is that we need to identify the goals of what it is we're trying to do and very specific conservation objectives that we're trying to achieve. In the past, conservation planning has focused almost exclusively on representing biodiversity patterns. So this means we might have species distributions, we might have some habitat types, and then we seek to represent them and achieve some of the basic marine reserve design principles that Lawrence kindly mentioned for me. What's been missing so far is incorporating some of the processes, or in large part what's been missing is incorporating some of the processes that influence and shape our biodiversity. And this is a big gap that I'm going to try to address today, at least in terms of our thinking about how we might incorporate it. But in addition, climate change is going to be affecting a lot of these processes, so we really do need to move forward to represent them. Specifically, I'm going to be talking about some of the spatio-temporal processes, so things that change in space and time, which are the things that underpin our biodiversity. More specifically, I'm talking about the disturbances that we've heard so much about, such as cyclones, coral bleaching, but also processes of resources, such as high areas of primary productivity, as in the satellite image. We're dubbing these, or borrowing a term from the ecology literature of patch dynamics to generally refer to these patchy resources and disturbances that change in space and time. Why are we wanting to consider them? Well, patch dynamics are important because many species depend on them. There are, for example, some that might be associated with different stages of post-disturbance succession, and others that track these patchy resources. More importantly, though, is that humans are increasingly disturbing parts of the ocean, and climate change is going to be affecting some of these processes. Climate change, we've heard about this over the last few days, so I'm not going to dwell on it, but the increasing intensity of storms, more bleaching events, rainfall patterns, such as you can see from the outflow of the Sepik River in Papua New Guinea here, are all going to be changing in intensity. So the aim of my talk today is to outline some of the things that we're thinking about in terms of incorporating these patch dynamics and climate change into conservation planning. The purpose of the work here, which is in collaboration with Bob Pressey, that many of you know, as well as others from Program 6 at the Coral Reef Center, is to develop a framework about how we might approach this. We're doing this initially through a few case studies. Some of the slides that I'm going to show you are about the Bismarck Sea. The reason we're focusing there is that we're collaborating with the Nature Conservancy, Jeff Lipset-Moore in particular, so that hopefully some of this work may lead to implementation eventually. We're also hoping to do some of this work in the Great Barrier Reef, although that's not yet started, and perhaps some other case studies as well. So overall, the framework that we're thinking about is first looking at the past. What can the recent past for which we have data, how can that inform how we might look at the future? Very specific to thinking about conservation planning is identifying conservation objectives in terms of how things are changing in these patch dynamics. And then finally, considering some of the scenarios of how our climate is influencing these patch dynamics into the future. I'm going to touch briefly on each one of these to give you some ideas of how we're thinking. I also wanted to mention here that we are just in the beginning stages of developing some of this work, and we hope that a lot of the work that you're doing on specific species or other issues might be able to feed into it. So I'm very interested in hearing ideas about how you think we might be able to collaborate on some of this important work. So first of all, the time series analyses. This is important both for setting the global context, how does your region differ or not from what's happening globally, and more specifically within the region that you're interested in. We've been using some satellite imagery to illustrate this. Satellite imagery is useful because it's available globally, and there are some time series available. So the examples I'm going to be giving are about sea surface temperature and net primary productivity. The satellite imagery is also important because there is some biological significance or biological correlates of this data, although we need to learn a lot more about that as well. For example, we know how coral bleaching is affected by sea surface temperature, but there are also certain species, such as different tunas, that have preferences for certain temperature ranges. So if those are changing, the species distributions are going to be changing as well. For net primary productivity, it might be seabird feeding areas that are closely correlated with areas of high primary productivity. So here's a global example of the sea surface temperature anomalies from 1982 to 2007, and whether or not there's a linear relationship in how they're changing. And as we've seen in other maps as well, things aren't changing uniformly globally. The study area in Papua New Guinea is here. This is roughly the Bismarck Sea. And this is why the global context is important, because things are changing much more rapidly here than they are in other regions of the world, which you can see if you zoom into the time series data for that particular region. The temperatures have been increasing, although highly variable. The same map for net primary productivity, again looking at anomalies over this time series where there really isn't much isn't anything different happening in this particular region. What's important then is to move into the study region that you're interested in to see what some of the spatial and temporal dynamics are. So some of the types of parameters that we're interested in is the persistence of these spatial features, their size, their shape, directional alignment, frequency, return period, and there are likely others as well. So I wanted to illustrate here, if you can click on the video back there. This is just a snapshot of the time series for a few years, where you can see in yellow is about the average temperature for that region. And over the years, you can see that you have some cold water intrusions coming in or periods that are very warm. This is simply to illustrate, as we all know, that things are not static, as we've presumed in how we've been doing conservation planning. This is looking at the standard deviation of sea surface temperatures for this region in the Bismarck Sea. And there's certainly an area where things are much more dynamic and much more variable than they are in other parts of the region. And this is something we haven't considered in conservation planning in the past, and I think is quite important. What you can also derive from this information is looking at the highly unusual events. So in this case, we looked at where temperatures are half a degree above or below average for the whole time series. So these are the two maps, with the first one being the areas that are more than half a degree, which is about 2 standards deviation more than above the average temperatures. And the second image is where they're below average. And again, of course, as represented by the areas of high standard deviations, you have some places that are much more dynamic than others. What you could also take at from this is where there might be regions that could act as refugia for certain temperatures and so on. We also mapped out the time series itself. Again, this is looking at the temperature extremes, where you can see that initially from the 1980s until the 90s or so, there was a lot more cold water as a percentage of the area than in the more recent years, where you see a lot more warm water. Again, this is net primary productivity, which has slightly different patterns. You can very clearly see the influence of a river plume right here, which changes over the years somewhat, but you can also see some intrusions here and here. Again, looking at the sea surface temperature standard deviation, of course, that particular feature is represented. And the time series shows that there's a much more seasonal influence here, and it doesn't seem to be changing certainly as much as the sea surface temperature. So the key question then is, what do you do with this information for conservation planning? This is where setting specific conservation objectives comes in. And we haven't specifically set the objectives yet, but this is going to involve work with managers as well as stakeholders and others to see what we might be aiming for. Some examples for resources might be that we look for the minimum extent of occurrence within a conservation system at any one time. We might want to look for these refugia, for example, areas that have frequent or abundant resources. Similar ideas for disturbance, you might want the maximum extent of occurrence of such disturbances in your conservation system. There might also be refugia or areas that have infrequent or low intensity disturbances. And again, you might also want a minimum occurrence of disturbance because disturbance isn't bad for all species and some certainly rely on it as well. And then finally, the third step of the framework in which we're thinking about it is introducing some of the climate change issues into this. You can take the past information to inform the future, coupled with some of the regional or global climate change scenarios from the IPCC, for example, to give you a sense of how things might be changing and how much uncertainty there is in the future. Then you can use that information to incorporate it into designing your conservation systems. So to conclude, of course, we can't protect all of the ocean because we don't have the resources to do so, and doing this kind of analysis is not necessarily fast or easy either. So a key question is, does it actually make a difference? What we're planning on doing here is looking at the way we used to do things, looking at patterns alone, see the priority areas you get. Once you incorporate some of the processes, how do things change? Does it make a difference? Once you incorporate some of the climate change considerations, do you get different priority areas or not? If you don't, then you might as well use the easier steps. And there are, of course, challenges which are faced in many places, limited data or lack of data, the link between some of those satellite images and the specific species, and the difficulty with some of these climate change scenarios. But ultimately, I wanted to conclude by saying that it's important that we start addressing these challenges, in particular how climate change is affecting our processes that many of the species and the biodiversity that we care about depend on so much.